Good afternoon, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today we have learned the subject on W3601 Protection and Switchgear for 2021 regulations. In this presentation, we have introduced the topic protective schemes or methods used to detect the faults in power systems and isolate the faulty session quickly to ensure the safe and reliable operations. Then we have to discuss overview and importance and applications of the power systems. So protective schemes are important because they prevent damage to costly equipment. So maintain UPS and ensure system stability. So they are widely applied in generation stations, transmission lines, substations, and distribution networks. Introduction. So protective schemes continuously monitor the electrical parameters like current and voltage. When an abnormal condition occurs, they detect the fault and initiate corrective action to reduce the damage and improve the system reliability. Then need for protection. So protection is necessary to prevent the severe damage to electrical equipment, and it ensures a continuity of power supply, safeguard human life and operating purpose. So without this protection, even small faults can lead to major system failures. Then basic components. So this slide explains the main elements of a protective systems. So relays, circuit breakers, current transformer and potential transformers. We know that the relays it detect the faults, and circuit breakers it isolate the faulty sections, and CTPT current transformer and potential transformers provide scaled electrical signals to relays. Then types of protective schemes. Different protective schemes are used depending on the system requirement, such as overcurrent protection, distance protection, differential protection, directional protection. So each type has a specific application and operating principle. Overcurrent protection. So overcurrent protection is a scheme that operates when the current exceeds a preset value. So it excess the current occurs due to overloads or short circuits. So it is one of the simplest and most widely used for protection methods. So need. It prevents damage to electrical equipment, and then it avoids overheating of the conductors. Then working principle. So current in the system is continuously monitored. So when the current exceeds the set pickup value, the relay operates and sends a trip signal to the circuit breaker, and the faulty part of the system is isolated. So application of overcurrent protection is used in distribution feeders, radial power systems, backup protection for transformers and generators, industrial power systems. Then we have to discuss the distance protection. So a distance protection is a protection scheme based on impedance measurement. So it determines the distance of the fault from the relay location. So it is mainly used for transmission line protections. So need for distance protection, the transmission lines are long and exposed to the faults. So overcurrent protection is not reliable for long lines. So we have to prefer the distance protections. Principle of operation. So relay measures the voltage and current at its location. So we have to calculate the impedance value Z equal to V by I. So if measured impedance is less than preset value, means the relay is operated, then send a signal to the circuit breaker. So indicates the faults within the protector zones. So the application of distance protection. It is used in high voltage transmission line, primary protection for long lines, backup protection in interconnector systems. Then we have to discuss differential protection. So a differential protection is a protection scheme based on the comparison of currents. So it compares current entry and leaving a protector zone. So it is mainly used for protection of important equipment. Then need for differential protection. So it provides fast and accurate fault detection, and it protects costly equipment, and it operates only for internal faults, highly reliable and selective. Then principle of operation. So current at the input and output of the equipment is measured. So under normal condition, input current is equal to the output current. During the internal fault, difference between the current increases. So the relay operated when the differential current exceeds the set value. So send a trip signal to the circuit breaker. The circuit breaker is disconnect the circuit. We have to protect the transformers, generators, transmission lines, etc. Application of differential protection. It is used in transformer protection, generator, bus bar, and motor protections. Then directional protection. So it is a scheme that operates based on the direction of fault current. So it ensures that the relay responds only to a fault in a specific direction. So it is used in interconnected power systems. So need for directional protection in interconnected networks, current can flow from the multiple sources. So overcurrent relays alone may cause incorrect tripping. So the direction protection improves selectivity and reliability, and it prevents unnecessary isolation of healthy sections. Next, principle of operation of directional protection. So relay compares the phase signal between the voltage and current. The direction of power or fault current is determined. So the relay operates only when the fault current flows in the set directions. Then send a trip signal to the circuit breakers. Conclusion. Protective schemes are essential for the safe and efficient operation of the modern power systems. So they improve reliability, reduce outage time, and protect both equipment and personnel. References. So the slides list the standard textbooks used for further study and academic reference in the power system, protection and switchgear. Thank you.